Alrighty, I'm back in my PHPP model now, and now that we have a little more familiarity with thermal bridges, why don't we talk about how we're going to enter that thermal bridging information into our PHPP model. So if you've been following along, hopefully you have a PHPP that looks something like this. I'm here in the areas worksheet, and as we saw in our last round of videos, we modeled out all of our opaque surfaces here in the areas input section. We also added our TFA information here. We tagged everything with the appropriate assembly type. And so all of our opaque assemblies here should be, at this point, working properly. So that's all well and good. We're going to leave that behind and we're going to move on to the next piece. We're going to start looking at what it's going to take to enter our psi values, our thermal bridges. So let me do this. I am going to scroll down a little bit. So I'm here in the areas worksheet, and I'm going to scroll down and down and down until I get to row 144. And let me zoom in a little bit here and let's see what we have. So notice in this section, once I get to row 143, I enter into a whole new section, which is where I'm going to be able to enter those thermal bridges. So again, I'm in the areas worksheet and I just scroll down until I got past all of the surface area inputs. And as I said, here I'm entering, or I'm able to enter my thermal bridges. Now the data entry here is going to be very similar to the surfaces. We're just going to go through and we're going to enter one thermal bridge at a time into our entry here. Each row is going to correspond to one thermal bridge. And you notice here we were able to put in a name, a group number, a quantity, a length, and then a psi value for that thermal bridge. So 4 pieces of information there that I'm going to need to enter, 4 or 5 pieces of information that I need to enter for each thermal bridge. And we're just going to go through one at a time and do that. Okay, well, so let's talk about what thermal bridges we're going to enter for our project. Let me open up my example files here. So I just have my example files downloaded off the Canvas website. And let's take a look at what we're building here. And let's talk about what thermal bridges we want to enter. So let me open up my drawing set here. And let's just take a look here. Okay, so we've got our home and our garage, and of course we're pretty familiar with this floor plan at this point. Zoom in a little bit here so we can see it better. This is our sample building that we have been working on. Whoops, as we have been going through. As we've been going through this course, so we're pretty familiar with this building at this point. And now we have to discuss what thermal bridges we want to input. So first of all, just working off the plan, one of the very first places that we're going to want to assess are going to be these corners. So notice I've got 1, 2, 3, and 4 different corners on this building, and those corners are almost always a thermal bridge. So we're going to want to look at those carefully and assess those. We're going to look at how the building is built at those corners, make sure we don't have any disruptions, check to make sure we don't have any lapse in our insulation continuity, make sure we don't have any thermal bridges there. So I'm going to say that those corners are going to be an important one. Obviously, the window installs are going to be an important thermal bridge. We're not going to enter window installs in this portion of the PHPP. We're going to come back and talk about windows a lot in the next series, and we'll talk about how we enter window psi install information then. So we don't enter windows in this part of the PHPP. This part of the PHPP is just for those non-repeating construction or geometric thermal bridges, things like corners or the like. Okay, so we've got our outside corners. That's going to be 1. And then if we scroll down a bit, we've got our second floor plan. We've got some of our, zoom out, we've got our elevations. Let's go to the building section. Here we go. So the building section. Okay, so we've got a couple of clear thermal bridges here that we want to capture. So first of all, just starting at the bottom, I'm going to have a detail here at the footing, which I'm going to need to capture. So this is going to be an additional thermal bridge. I'm definitely going to want to enter in that footing information because obviously we're going to have a change in the way the building is built there. We have the effect of the soil. There's going to be all sorts of things that we're going to want to capture about that thermal bridge. And then the other one that we're going to want to capture, I would say, is going to be this eave detail. So how does the wall meet the ceiling, and then what happens as a result of the roof assembly there. So how is this detail effectuated? How is this build? How is the building built at this point, and how is it going to affect our thermal performance? So I would say that we've got three thermal bridges that we want to capture for our building here. We've got our floor or our footing detail, we've got our eave detail, and we've got our wall outside corner detail. Now, we might have more details. You might say, well, what about this interstitial floor detail? What about interior partition details? What about, I don't know, maybe there's some reinforcing or column details or something. Sure, there might be a bunch of other details we might want to take a look at in the future. It sort of depends on how you're building the building. For our purposes in this course, we're just going to do those three details just to give you a flavor of the process. But obviously, for your actual projects, you're going to try and capture all of the actual details, however many there are, wherever those thermal bridges occur. You're going to try and just build those into your PHPP model. Okay, so those are our three details that we want to enter here. So let me put this off to the side and let's talk about those three details. So how is the building built at those locations? Well, to understand that, why don't we go into our example files again. So I've got my example files open. Let's go into our O4 detail sketches and let's take a look at what we have here. So we've got a bunch of sketches from the design team that have some proposed construction types or some proposed construction details here. And notice that we've got one for the footing, and we've got one for the eave, and then we've got a bunch for the windows. So again, we'll come back and talk about windows at a later date. For our purposes, let's focus on these two right here. So we've got a footing and an eave detail. So let me open up the footing detail, and let's see what that one looks like. Oops, okay. So here's our proposed footing detail from the design team. This is the sort of proposal, and of course then it's up to us as the Passivhaus consultants to decide whether this is acceptable or not, whether this is good enough. Let me zoom in a little bit, see if you can see it a little better, whether this is sufficient, or whether we have surface temperature problems or heat loss problems, or whether this is good enough. Okay, so that's going to be one of the things that we'll assess here. So what do we have though? Well, obviously we have our insulated floor slab, and we have our double stud wall. We have this frost wall here, and notice that we have something of a haunch here, which is actually supporting the load-bearing stud wall on the outside here. We've got the insulation that turns up in a nice continuous fasten. So we do have some constriction of the insulation. There is some thinning of the insulation at this point, but overall, I would say we've got pretty good insulation continuity right here. And so if we are actually able to build it that way, I think, just as an estimate, it will be in pretty good shape. Notice also that the team is saying that they'll do an inch of insulation on the outside of the foundation in order to try and keep this warmer and reduce the overall heat loss. And of course, we've got our typical spread footing there, and since this building is in a cold climate, we're going to put that spread footing down below grade, the code required distance for avoiding frost issues. So, okay, so that one's pretty straightforward. So we want to model that in. We want to sort of take into account that guy there. And what about the eave? Let me look at the eave detail. Let me pull up the eave detail here as well. So here's our proposed eave detail where the wall transitions to the ceiling. So you can see here that the proposal for this project is we've got our double stud wall, and then we're going to do a wood truss, a vented attic wood truss assembly for the roof. And so notice here also that the team wants to use a raised heel or so-called energy truss, right? That's a common technique in wood framing for high performance buildings. And what that allows you to do is get this vertical offset in your truss so that you can get full thickness of your insulation all the way to this outside face. In a typical truss where this upper rafter element was sort of down here, you'd have a constriction in your insulation assembly as you move to that outside corner. So these raised heel energy trusses are great for getting full continuity of insulation all the way around. Okay, so this is the proposal for our eave detail. So we have those two proposed details, an eave and a floor assembly there. All right, so hopefully that all makes sense. When we come back in the next video, we will actually take a look at the PHPP. So that's a sort of just overview. We'll come back in the next video and we'll actually start entering these various bits of information into the PHPP. So how are we going to enter those bits in? Well, we'll look at that in the next video.